So I'm going to be doing a snap circuit project. I just got this kit in from the United States. It was held in customs for a while, so I hadn't had a chance to do it. So I'm just looking through the instruction booklet, and there are a ton of pieces of information about the circuits, what to do, specifically what not to do, and how not to short circuit your circuits. So I'm going to do project number 10 because we are just finishing a space unit in my class, and I think this would be something cool just to show the kids. Okay, so I built the circuit. It was a little confusing. It was really hard to tell when things should be layered or not. I'm not really sure if I did this right. I think I did, but I'm gonna try it now and see what happens. Okay, the light's on. Okay, so I've done something wrong. All right, I'll come back. So I took it apart a little bit because I found the alarm really annoying and wanted to hear what just the space sounded like. So I took off this whole section with the alarm and some of the connectors, and I took one of the wires off because it said that the wires are made for unusual connections. So I just took the red one and connected it directly from here to this one. I'm not sure if that's going to do much, but we'll see. Let's see if it works. Oh, it does not. Okay. So I've decided to start back at square one because I don't really understand how those circuits connected. So I think that if I start with just project number 1 and work my way up, that it'll be a little bit easier to understand how this all snaps together. Okay, so this is project number 1, just with the simple switch, the light, and the snap wires. All right, it works. I understand how this works. This is an open circuit. There we go. So this is project number 2 with the DC motor and switch. And so I just replaced the lamp with the motor for the fan. Okay. So I used the wrong switch for this. This should have been a flip switch. So, okay, that works. But then it says that after the music has stopped, I should be able to clap my hands close to the whistle chip or tap it with my finger and it should keep going. So, let's see. Oh. So it's not necessary for the circuit, but it adds something to it. So this is project number 4, and the only difference is that I put this resistor in. Everything got a little bit bigger here and here, but just the resistor in because it's supposed to make it quieter. So that is a lot quieter. And the same thing with the whistle switch here. It says that you should be able to clap above it and it should make the sound. All right. So I took off the resistor because it said it makes it quieter. So I'm seeing if the same setup will work with without the resistor and if it will be a lot louder. Oh yeah, definitely. So this is project 6. I accidentally skipped over 5. But this one has the fan and the light. But when I remove the light from the circuit, the fan moves a lot faster, so just showing that it sucks a lot more power. And the fan pops off at that point. So I went back and tried project 5, but I added in an extra wire, snap wire here, because I didn't want to move all of this. So turning it on, it's not as bright and the fan doesn't go quite as fast. I'm wondering if I built it with less of a connection, if it would be stronger. But certainly when it had its own connection. Oh, parallel circuits. So that makes sense. Because it has more than one pathway to follow. Okay. I'm slowly getting this. So I tested Project 6 again just to make sure, and yes, in fact, it is a lot brighter and a lot stronger with the multiple connections. So continuing my journey to project number 10, I've done project number 7 with the light emitting diode. I'm not sure how to say that. But anyways, it talks about these resistors and how the resistor helps the flow through the circuit without overpowering the LED and not burning it out. So there we go. So it says you should never connect this directly to the battery because it'll be too strong. So, you know, that makes me think about the appropriateness of this for some kids because this really, really requires to really pay attention to the steps of what you're doing in order not to ruin the project. So that's something that I'm thinking about. So this is project number 8, which isn't much different from 7. They just have you switch around this, the LED light, because it's explaining that the LEDs prevent the electricity from flowing in more than one direction. So let's see if it works. Nope. Okay. So this is project number 9, which is the project right before the space war that I started with. And this one just asks you to use a paperclip to connect these two together. I think this would be really good for students to experiment with what types of materials conduct electricity. So this is a wire I had from one of my old projects. It's hard to keep it steady, but it does light it up. And then I've got, the closest thing I've got to a paperclip is this giant star earring. So I'll try that. So I think this would be really good for students to test out different materials. This is a magnet. Okay, magnet does not help. So I think this is a good one because this is sort of more the level of my students. So going from project 9 to project 10 is a huge jump. And I've noticed here that project 11 and 12 are quite a bit more simpler than project 10. So I'm not sure if maybe that's not maybe the best place for project number 10 because it was a lot more complicated. So I think for me, my vote would be maybe project 9 and any of the prior projects because they're a little bit simpler, and then challenging students with these, you know, project 10. But I think they could equally skip 10 and go 11 and 12 because those ones are a little bit simpler, and, you know, 13 and 14 even seem like they would be a little bit easier for students.